Hi all, this is P01 Cyan presenting. As known, our goal was to build a virtually functional minesweeper in regards with its mechanical, mechatronics, electronics, and software systems. Without further ado, let's get started. Let's have an overview of the mechanical structure of the machine. The completed machine had a length of 219.73 mm, a width of 109 mm, and a height of 108.21 mm. The width of the machine had been maintained to be less than the desirable width of 140 mm, but the length on the other hand wasn't. This was mainly due to the Mechatronics systems used in the machine, which is this, which consists of a circular plate with a diameter of 44 mm. The machine weighed about 0.35 kg, which was about 40% of the recommended/desired weight of the sweet spot. The machine had also met all of the mechanical constraints proposed. This of course included that the machine would be traveling on ground. The machine had also been constructed in a way that every necessary edges has been chamfered, ensuring the safety of the user. The motor chosen to be used for the machine was Tamiya 70168 double gearbox kit, and the gear ratio selected was 115:1 ratio, due to its balanced output of speed at 160 meters per second at no load, which has been mathematically proven to be capable of finishing to cover the enclosed area within 5 minutes, and a total view torque at 0.6563 at full load. Now let's get into the Mechatronics system. The Mechatronics system utilized a cylinder disc reservoir, right here, and a servo with a circular plate connected to it. So this is a servo, this is a circular plate. So when the machine detected a landmine, the servo at the front would rotate 1/6 of the revolutions to release one of the token from the reservoir. This design not only minimized the power consumption, but it also saved the onboard available space, right here, for other components. The machine featured a continuous track drive system that were commonly used in tank and heavy-duty vehicles. This drive system would ensure the machine to overcome the most extreme situations without failures, due to its even spread of weight across the sport. The chassis of the machine was designed to be a universal platform where parts could be easily attached to. This function was provided by the idea of 156 mm by 56 mm plate with holes of 3 mm diameter drilled on it. This had not only ensured the expandability of the machine in the future, but also made the construction of the machine to be a bit more effortless. This design with the chassis of holes drilled on it had also helped reducing the weight of the machine itself.
This session demonstrates the electrical system of the prototype of an autonomous landmine sweeper. Here is the layout diagram for the entire vehicle. The electrical system of the vehicle consists of Tamiya 797 trim module, an Arduino motor sheet, a servo module, an ultrasonic sensor HCSR04, LED, one triple axis magnetometer HMC5883L, and was powered by a 9-volt nickel metal hydride. This figure here shows the schematic diagram of the electrical circuit with the connection to the Arduino. For pins configuration, analog pins A4, A5 were connected to the SDA and SCL of the magnetometer. Digital pins D2, D4 were connected to each of the resistor. D8, D9 of Arduino pins to trigger an echo of ultrasonic sensor, while servo pins were connected to digital pin D3. The power supply chosen was nickel metal hydride 9-volt battery, which is rechargeable with a long lifespan. So even if the battery is charged and not in use, the charge will not deteriorate. Besides, this battery is environmental friendly and can be recycled. Table A indicates the consumption mAh of the electrical components. The total consumption was 261.77 mAh. As the battery capacity is 300 mAh, the calculated battery life is 1.14 hours. This demonstrated that 9-volt battery was an ideal power supply for the vehicle. The vehicle needs a navigation sensor and magnet detector in order to function. We use a decision-making metric for the sensor selection, which can be shown in Table B. From Table B, it can be observed that the ultrasonic sensor is the best choice for navigation sensor, while the magnetometer is preferable for magnet detection. The ultrasonic sensor will be implemented to control the direction of navigation to avoid obstacles in the field. The time travel between the ultrasonic wave and the obstacle allows the sensor to measure the distance, while the triple-axis magnetometer was used to detect fluctuations in the magnetic field of the Earth. The change in the voltage is then used to get the magnetic field direction in the field.
After the software is activated, the vehicle remains in linear motion until something blocks its path. As it approaches the obstruction, it progressively slows down to a halt. The ultrasonic sensor then scans left and right, and the minesweeper takes the clearest path by comparing the two distances. Once it moves to the left, the vehicle faces forward again to scan if there is still something blocking its path. When a barrier is detected, the minesweeper turns around and continues. Once the magnetic field strength is passed, the minesweeper will mark the landmine. This includes rotating a servo such that a token is dropped each time. Program then proceeds to change the path of the algorithm as described earlier. This evades the landmine. After the minesweeper evades the object, it will continue onto its main loop and adjust its direction accordingly. The software begins by defining all the pins and importing all the necessary libraries from the Arduino library set. The main loop consists of some if statements, and there are if statements nested within them. So the initial if statement just gets the distance of the minesweeper from the object or barrier that is directly in front. And as you can see, distance is calling the search function and returning the amount of centimeters in front of the sweeper. So if the distance is less than 30, and if the magnetic field strength has not passed the threshold, then it just changes the path of the minesweeper. If it's past the magnetic field threshold, as always, it blinks the LEDs, and it's going to mark the landmine as programmed. Else, if the distance is greater than 30 centimeters but less than 60 centimeters, the speed of the motors will be reduced by 0.75 times. Else, if there's no obstruction and the magnetic field threshold has not been passed, then it's 100% speed ahead. Else, if there is a landmine in front, then it's going to blink and mark as expected. The change path program works as expected. It stops and halts the minesweeper. It moves it slightly backwards so there's a better vantage point. It defines the servo. It delays, and then it turns the servo to the right and runs a search function, It delays, and then it rotates the servo to the left. It gets the left distance, it delays, and then it returns it to its original position. And then this data from left distance and right distance are passed to the compare distance function. As you can see again, there are nested if statements and else statements in the compare distance function.